Hello everyone, in today's lesson we will investigate the use of the sigma notation. The definition: the sigma notation is a sum of n terms, a sub 1 to a sub n. Written in expanded form is a sub 1 plus a sub 2 plus a sub plus a sub n. The expanded form of writing this is inefficient because you have to write a whole lot of numbers, but in sigma notation you simply write the sigma sign. K equals 1 to n of a sub k. K is the index of summation. A sub k is the kth term of the sum, and the numbers 1 to n are the lower and upper limits of the summation. I find it very useful. The summation k is equal to 1 to n of c, where c is a constant, is equal to c times n. The summation k equals 1 to n of k is equal to n times n plus 1 all over 2. Summation k is equal to 1 to n of k squared is equal to n parentheses n plus 1 parentheses 2n plus 1 all over 6. And the summation of k equals 1 to n of k cubed is equal to n parentheses n plus 1 all over 2, all of that squared. But suppose we wanted to expand this summation notation. Summation k equals 1 to 4 of 3x. So k squared plus 7. So writing out each of these terms, begin with k equal 1. We will plug in 1 for k here, then 2 for k, then 3 for k, and then 4 for k. So that will be equal to 3. 1 squared plus 7 plus, because we're summing, we use a plus sign. 3, 2 squared plus 7 plus 3 times 3 squared plus 7 plus 3 times 4 squared plus 7. That's the way to expand it. If we're using our special summation formulas that we just learned, we could break this up into two parts. Summation k equals 1 to 4 times 3k squared plus 7 can be broken up into summation k equals 1 to 4, 3k squared plus summation k equals 1 to 4 of 7. This 3 can also be pulled in front of the summation sign by our scale of multiple ideas that we learned earlier on. So it'd be 3 times, using the basic formula that we had over here, general formula. So the n times n plus 1 and 2n plus 1 over 6. You can just plug in 4 wherever you see that n, because our formula was k equals 1 to n, so our n was equal to 4. And then plus, we want to use the constant formula, so that would be 4 times 7, or n times c. Write in expanded form. Summation k is equal to 1 to 8 of 1/4 ln of k. In this problem, we will be inputting k is equal to 1, 2, 3, 4, 5, 6, 7, 8 into this expression, and then adding them. So k is equal to 1 to 8. The summation of that, 1/4 ln of k. We can, by the constant, by the scalar multiple idea, pull the 1/4 out, and so that becomes 1/4 summation k is equal to 1 to 8 of ln of k, and then write at 1/4 parentheses ln of 1 plus ln of 2 plus ln of 3 plus ln of 4 plus ln of 5 plus ln of 6 plus ln of 7 plus ln of 8. ln of 1 we all know is equal to 0, so we can replace that very common idea here. So that's 1/4 of 0 plus ln of 2 plus ln of 3 plus ln of 4 plus ln of 5 plus ln of 6 plus ln of 7 plus ln of 8, and we are done. Let's try another problem. The sum below is in expanded form. Write the sum using sigma notation, where the lower limit of the summation is k equals 1. Now what we want to do here is that we want to look for a pattern in these numbers and then write that pattern as your formula. Okay, so let's go ahead and look for a pattern. We have the numbers 6 plus 12 plus 24 plus 48, right? 6 is the same as 6 times 1. 12 is the same as 6 times 2. 24 is the same as 6 times 4. 48 is the same as 6 times 8. We know our index k begin at 1, k is equal to 1, maps with 6, k equals 2, with 12, k equals 3, with 24, and k equals 4, with 48. So let's factor out our 6. Let's factor out our 6. So we have 6 parentheses 1 plus 2 plus 4 plus 8. And then let's see if we can see a pattern in these numbers, 1, 2, 4, and 8. Obviously, 2 times 1 gives 2, 2 times 2 gives 4, 2 times 4 gives 8. So these are all powers of 2. So how do you write 1 as a power of 2? 2 to the 0 gives 1. 2 to the first power gives 2. That's 2 as a power of 2. 4 to the 4 is the same as 2 to the second power, and 8 is the same as 2 to the third power. Can be written that way. So now we have 6 times, parentheses, 2 to the 0 plus 2 to the 1 plus 2 raised to the 2 plus 2 raised to the 3. And then at this level, we want to compare these exponents with the indices, the k's. So k equals 1 maps with the exponent of 0. K equals 2 matches with the exponent of 1. K equals 3 matches the exponent of 2. And k equals 4 matches with exponent of 3. So we're looking for a pattern here. Notice here that 0, 1, 2, 3, and 1, 2, 3, 4 are the k's. The exponents on the 2, they are 1 less than the index numbers. So then you could say that 0 is 1 minus 1, 1 is 2 minus 1, 2 is 3 minus 1, and 3 is 4 minus 1. So where the k's are 1, 2, 3, and 4. So as a very simple rule, then we can write these as k minus 1s. So then our final answer will be something like summation k will be exactly summation k is equal to 1 to 4 of 6 times 2 to the k minus 1. So that is what our answer in summation notation would look like. You can check or finally write the way that summation k is equal to 1 to 4 of 6 times 2 raised to the k minus 1 equals 6 plus 12 plus 24 plus 48. Because if you plug in these values for k, you will have these extended outcome. Let's look at an example where we will relate area under a curve and use these summation notation ideas. Estimate the area under the curve, f of x is equal to sine of x between x equals 0 and pi over 2. Using left endpoints and 4 rectangles of equal width, make a rough sketch of the graph and use it to decide whether your estimate is an overestimate or an underestimate. So here we've made a sketch of our rectangles. Make sure we're keeping them above the x-axis, and the left edges are just touching the graph of f of x equals sine of x. It's a little bit rough, as you can see. So this is your f of x equals sine of x. And then we want to make sure that just the left endpoints right here of the rectangles, that they touch the curve. The left endpoints only touch the curve, right? So you can see a little bit more probably right here. Okay, so something like that. Okay, so what we want to do then is we want to break it down into 4 rectangles. That's what we did. Or n was equal to 4. N was equal to 4. 2n was equal to 4. So let's do that. N was equal to 4. So a was 0, b was pi over 2. So your delta x would be equal to pi over 2 minus 0. That's b minus a over n. So our answer would be pi over 2 minus 0 over 4. And so that gives you pi over 8. And then these left endpoints, we're going to title them C sub k, so that left endpoints will be 0, pi over 8, pi over 4, and 3 pi over 8. So we're going to do that, and then we're going to find f of C sub k, which should be the sine of 0, sine of pi over 8, sine of pi over 4, and sine of 3 pi over 8. The sine of 0 and the sine of pi over 4, we easily know that from the unit circle. The others we're going to leave as is, and then we're going to plug that into our area formula. Area will be equal to summation, k is equal to 1 to 4, delta x f of c sub k, and then we just plug these in. Your delta x is pi over 8, and then bring these numbers down to 0, plus the sine pi over 8, plus the radical 2 over 2, plus the sine of 3 pi over 8. And then we have to determine whether it's an underestimate or overestimate. And we determine that it's an underestimate because, looking at our diagram, the rectangles, they lie below the curve. They all lie below the curve. So because of the fact that those rectangles lie below the curve and you have some white spaces here between the curve and the rectangles, then the area estimated by the rectangles is an underestimate. Thank you so very much for watching. Like and subscribe. See you next lesson.